So I hope this audio is better. Okay, cool. So let us start the class. As usual, I have something wonderful today. So I just wanted to ask you this question. If any of you know answer to this question, okay, so I'm going to change the settings. 1 second. Okay, so the question I'm writing it on the screen. You can just see it on your screen, and you can send me the answer via chat. Okay. Okay, the question is, which place is considered as Asia's cleanest village? Okay, Asia's cleanest village. I'll give a hint. Hint, that village is in India. Okay, so you have to tell me what is the name of that place. Okay, so some of you are sending me answer. Santosh correct, Mayuresh correct, Kavish correct, Suhani wrong. I asked village. Okay, which is the cleanest village? I did not ask cleanest city in India. Cleanest village in entire Asia. Okay, cleanest village in entire Asia. Nesar correct, Sneha correct. Uh, Saket, I want the name of the place, not state. Okay, fine. So let us see the answer. Okay, so apparently this place is also called as God's own garden. Okay, so this is our Ma Lin Ong. Okay, the name of this village is Molinong, which is in Meghalaya. Okay, so I was telling you the other day. Okay, so if you remember that I had been to IIT Guwahati. Okay, so for the convention. Okay, so as I told you. Okay, so this group of people. Okay, so since we had some time. Okay, so we thought we'll have a complete trip of Northeast. Okay, and hence we decided to go and see why exactly is this place called Molinong considered as the cleanest village in Asia. And trust me, it is actually clean. Okay, it is actually clean, and this was a great experience. So let us go and see this wonderful place. Okay, in Meghalaya called Molinong. Okay, which is considered as the Asia's cleanest village and also God's own garden. Okay, so and also we'll see some other cool places of Meghalaya. It's a like wonderful state. Okay, you also have Chirapunji and all those. Okay, and you also have this river called Dauki, which is like bloody transparent. You can actually see the bottom of the river. It's that clean. Okay, absolutely not polluted. Okay, so let us dive into Meghalaya and have this great experience, and then we'll continue our chapter. Okay, so just to ensure that you people have the experience of audio, so I'll be using this speaker. Okay, if you cannot hear me, send me via chat. Okay, if you cannot, I think you should be able to hear via speaker. Okay, so let's start uh, the video. 1 second, I just connect the speaker.
Sometimes when I wake up in the middle of the night, I'm able to feel, almost reach out and touch the littleness of my being. And then I ask myself what it means to be alive, to be able to breathe and walk and touch and see. In these moments, I'm forced to believe that there's a greater purpose for every one of our lives on this planet. The quest to truly understand this purpose led me to Meghalaya last month, and I came back with more answers than I hoped to seek. Out there in the woods, the structures of modern world begin to turn hazy. The rulebook of society, with its definition of money, religion, and human identity, starts to become irrelevant. And then, with every single step, you pull yourself away from comfort and push yourself a little bit towards the unpredictable. Nature draws you in and gently lets you out. For once in your life, you embrace the happiness of not knowing what lies ahead, and you realize that rulebooks are for the shelves. Life is right there, out in the open. The people of Meghalaya left me wondering if it is indeed possible to hold time space. You see people happily waiting with their fishing nets, at peace with the way of life they have built for themselves. Warm and hospitable, they have struck a smooth balance between advancement, nature, and tradition. Their world full of local folklore, simple trade practices, and a sharp sense of culture and simplicity has paved the way to happiness.
That's what is the benefit. The grand benefit. I'm thinking about for the future after maybe 40 years, after 35 years, which will be living the
Pack your bags and hit the road. You may not come back with answers, but you'll surely find questions that lead you to self discovery. Your time on this planet is limited. Your quest to explore is not. You make the world and the world makes you. So while you can, take the leap. Go out, jump in, fly away.
Okay, so uh, That was the beautiful Meghalaya. Okay, I'll again change back my settings. Okay, fine. So I think you can hear me now properly. Okay, so uh, that was an entire Meghalaya where you got to see the Maulinong also, the root bridge. Okay, as well as there's some fantastic places. Okay, the root bridge, then River Doki, then you have this Maulinong, as well as Chirapunji, where it's always raining. Okay, and you just feel that you're in the middle of clouds. Okay, so amazing experience. Okay, so I got to remember some great memories of my college days. Okay, so it's a great place. Okay, so overall, the Northeast is just beautiful. You will realize that you are much closer towards nature. Okay, so it's a fantastic. You can definitely have a visit. Okay, so once all this corona vacation, all this corona, like is gone. Okay, fine. So anyways, so with that great video, we'll just start our class. Okay, so a quick recap. So we were doing the distance time graph. Okay, so just to check whether you still remember what we were doing few days ago. A small concept test. Okay, a small concept test as usual. So I'm going to draw one graph. You have to tell me what is the nature of this graph. What does it indicate? Okay, sorry. So what does this indicate? Okay, is the question. What is the nature of this DT graph? Okay, so that means distance time graph. Okay, so I'm going to give you the options. Okay, option A, non-uniform motion. Option B, uniform motion. And option C, rest. Okay, so three options. I'm just going to launch the poll. Okay, so easy, simple. I expect all of you to give me correct answer. Okay, so on your screen, you can select the option. Okay, so fast. So last 5 seconds. So 5, 4, 3, 2, 1. Time up. Okay, so I'll just share the result. So on your screen, you can see that almost 94% of you have selected the correct option. Somehow 6% of you, selected wrong option or whatever. Okay, so this is a straight line. See, whenever you have this straight line graph, okay, so that definitely tells you that it is a uniform motion. Okay, so non-uniform motion will be of any other shape, any other random shape, parabola, hyperbola, whatever. Apart from straight line, if you see any other random shape, then you should go for non-uniform motion. Okay, great. So the last class we have done about distance time graphs. Okay, so this class we'll be dealing with displacement. Okay, so this class we'll do displacement versus time graph, along with that velocity versus time graph. Okay, in which the velocity versus time graph is much more important. You can expect more questions from velocity time graph. Okay, so let us see what is this displacement versus time graph. Okay, and what information does this graph give us? Okay, so fine. So the first point, it indicates the displacement with respect to with respect to time. Okay, so where displacement is on y-axis. Okay, so displacement is on y-axis and time is on x-axis. Okay, so basically just like distance versus time graph, you just have similarly displacement versus time graph. That's all. Everything else is same. Everything else is same. Okay, the interpretation varies. Okay, the interpretation varies. So let us see how does it vary. Okay, so in the next slide, see, like the best thing is, if you have time, if you can quickly write it down, you write it down. Okay, so or else you can use technology, you can take screenshot, you can take screenshot, or you can take photo, whichever is convenient for you as per the device that you are using. In laptop, if you want to take a screenshot, there is an option called print screen. You can print screen, then go to paint, and then you click on control V, copy paste, it will be there, then save the file, again come back. That's all. In mobile, I think it's pretty easy. All of you know how to take screenshot. Okay, so however it is, I'm not going to repeat. Next time onwards, as soon as I'm done, no, whatever I'm going to write it on the screen, please save it. Okay, by taking screenshot, photo, whichever is convenient for you. Okay, great. So now the next slide is the interpretation, what we can understand from displacement versus time graph. Okay, the slope of displacement versus time graph. The slope of displacement versus time graph gives velocity. Okay, so the slope will indicate velocity. Okay, so that is what we can understand from the displacement versus time graph. Okay, the displacement versus time graph will tell us regarding the velocity. Okay, so how to find the slope? The previous class I told you. Okay, so that is y2 minus y1 divided by x2 minus x1. Same logic, same technique. If you just follow with the displacement versus time graph, you will get velocity. You will get velocity. Okay, that's all. The previous class we had in fact taken a table. If you remember, we plotted the graph. Okay, so then we got the values. I had done separately for three things: uniform motion, non-uniform motion, as well as the object which is at rest. The same type, same logic, you're gonna do it for the displacement time graph, and everything else remains the same. The only thing different over here is this quantity velocity. Okay, so since displacement is a vector quantity, hence when you find out the slope, you will also find out that it is nothing but our vector quantity velocity. That's all. Okay, so I'm gonna just take one quick example. Okay, in order to let you know how exactly you have to find it. Okay, so I'm just drawing the graph directly. Okay, and using this graph, I'm going to show you how to find the velocity. Okay, how to find the velocity. Okay, so this is my graph. So you can just quickly see here. So I have time on x-axis always because it is an independent quantity, and on the y-axis I have displacement. Okay, of course you have to mention scale and all those things. So now I'm gonna just plot the graphs right away. So suppose, sorry, this is my graph like this, straight line. Okay, straight line graph. Okay, so then I am having the points. I'm having the points like this: 0, 1, 2, 3, 4. Similarly, 1, 2, 3, 4. So I just have, I'm just for an example, I'm considering the following points. I'm going to show it in the color yellow. Okay, so I have just taken the points A and B, where A is 1 comma 1, B is 3 comma 3. Okay, so B is 3 comma 3. So if they ask us to find out the velocity from the following graph, okay, so then we're going to do like this. Okay, so velocity is equal to the slope of the graph. Okay, the slope of the graph. Okay, so that is given by the formula y2 minus y1 divided by x2 minus x1. Okay, so now what are our points? I'm going to write our points over here. So that is 1 comma 1 and point B 3 comma 3. So if you carefully observe, this will be my x1, this will be y1, this is x2, this is y2. Okay, so I hope all of you know the coordinate geometry. You have already plotted the graph, and I'm pretty sure that it's simple enough. If it is not, then let me know. We can do one what do you call revision class or backup class later before the test. Don't worry. Okay, so any concept, if you're not aware, you missed it or something, whatever the reason is, just let us know later. Okay, so that we can have one revision class. So the x coordinate are there, the y coordinates are there. You just got to substitute it. Okay, so y2 is 3. I'm going to write it here. Then y1 is 1. Similarly, x2 is also 3 and x1 is 1. So when I do this, so I will get the answer as 1 meter per second. Okay, so that is the answer. Okay, so that is our velocity. Our velocity in this particular motion is 1 meter per second, and this is going to remain the same because this is our uniform motion. This is our uniform motion. Okay, as simple as that. Okay, just like our distance versus time graph, we have the same situation with displacement versus time graph. Okay, so another thing you need to understand is that in displacement versus time graph, since we are dealing with vectors, okay, it can be a positive slope, it can also be a negative slope. Okay, so in the negative slope, we'll understand that it is negative displacement. Okay, this is positive displacement, uniform motion only, but positive displacement is going up. If it is the other way around, uniform motion only but negative displacement. Okay, so anyways, so when we're doing some problems, we'll come across such type of questions. That time we will get into it deeper. Okay, so the next thing, the important thing that we got to learn is this: velocity versus time graph. Okay, so velocity versus time graph. Okay, so this is what is important for us, and you can expect questions majorly from this. Okay, so what exactly is this velocity versus time graph? As the name indicates, okay, it is having velocity on the y-axis and time on the x-axis. Okay, it indicates the change in velocity with respect to time. Okay, it indicates the change in velocity with respect to time. Okay, so now the important one is not the definition but its interpretation. Okay, what you can understand from these type of graphs. Okay, the first and foremost you need to realize is that, okay, in velocity time graph, the slope indicates acceleration. This is the most important thing. The slope of the velocity time graph gives acceleration. Okay, and the second most important thing is the area under VT graph. The area under VT graph indicates displacement. Okay, sorry, I have to write magnitude of displacement, because the area cannot tell you the direction and all that. Okay, because area is a scalar. Okay, so hence here also you will just get only the scalar thing. The area under BT graph indicates, one second, indicates the magnitude of displacement. Okay, magnitude of displacement, or that is nothing but our distance itself. Okay, I'm going to underline with some other color, green color, so that you're going to understand easily. Or else I just put a box. Whatever I put in the box, no, that means it is an important quantity. That's all. Okay, so these three things you should be aware of: velocity versus time graph. Okay, so the velocity versus time graph is a graph which indicates the change in velocity with respect to time. Okay, where the velocity is on the y-axis, time is on the x-axis. Time is on the x-axis, velocity is on the y-axis, always, because time is independent quantity on the x-axis. Keep that in your mind always. Okay, so now the next important thing is the slope. Okay, just like we had slope for the displacement versus time graph, and we had slope for distance versus time graph. Similarly, we have slope in velocity time graph also, but this slope will indicate acceleration. See, I put it in this blue color box. Okay, that means you have to remember this. Just remember two words: slope, acceleration. That's all. Okay, the slope of velocity versus time graph gives acceleration. Okay, velocity versus time graph, the short form of writing that only is VT graph. V stands for velocity, T stands for time. So velocity time graph can also be written as VT graph. That's all. Okay, so the another thing is the area. If you find out the area under the graph, that will tell you the distance. That will tell you the distance or magnitude of displacement. We'll consider at this scenario that they both are one and the same. Distance or magnitude of distances is considered as same in this context only. In this context, that is while finding out the area of the graph, especially VT graph. Okay, in this only we are finding area. In distance versus time graph, if you find area, you won't get anything. Here, if you find area, you will get distance or displacement. Okay, so this is the most important slide of today's class. That's why I'm marking this symbol. Write it down, or take a photo, or take a screenshot. Do it now. That's all. Okay, we're gonna see one example and we will implement all this in the examples. You wait. Okay, have patience. Once we do one example, you will understand it better. Okay, so now quickly write this down or take a photo or something, and as soon as you're done, you just click on the S icon. Okay, you click on the S icon so that I am aware कि you noted down the important slide of today's class. Okay, this slide is the most important of today's class. So it's better you note it down or take a photo, whatever you want to do. Okay, fast. So I want at least 95% of you to finish it. Then only I can move to the next topic. Okay, I just see that only 50 students have completed this. Okay, so you just take a photo or a screenshot or write it down. Right, I prefer you to write it down because that is a great learning practice. Okay, because photo you may lose it or you may delete it later or whatever. But if you write it down, your brain also remembers something. Please write it down quickly. Okay, fast. And see, while I'm teaching, I cannot take down all your chats. It just completely distracts me and it will just lower the speed of teaching. Hence, whatever chat is there, you have to direct it to Srinidhi ma'am. Okay, so madam will take down all your doubts, your queries. Okay, so I'll be just super focused only on teaching. Okay, so that we can do some good questions in less amount of time, because I have back to back classes. Okay, and I will not be able to kind of spend so much of time with you guys. So that's why I want to make the most of it. Every minute for me counts. Okay, so hence all your doubts, divert it to Srinidhi ma'am. Okay, queries, yeah, whatever it is. Okay, so as much as possible, I'll take down your notes. Okay, your doubts whenever. So others, please do it fast. Once you have taken down this, you click on the yes icon. I'm still waiting. There are only 70 students who took photo. Yeah, you wrote these things. Others, please click on yes icon quick. Okay, fine. So now let us see how do we solve questions based on BT graph. Okay, how do we solve questions based on BT graph with the following example. Okay, so I'm going to make a table. Okay, so I expect you to draw the graph. Okay, quick. Okay, so let's do this fast. So I'm going to make a table. So this is my velocity. And this is my time. So velocity, of course, measured in the meter per second, and time in second. Just a second, I'll just change this. Okay, so now for the following data, quickly plot the graph. Okay, for the following data, quickly plot the graph. So I'll just make it simple for you. Okay, so that's I'm taking an easy example. We will see some module questions from the like the worksheet, and solve some of those also. Okay, first we'll start with simple and easy, so that your confidence is high. Okay, so boost your confidence. Okay, plot this graph fast. Let us see what type of graph are we expecting. So once you're done, you know what you're supposed to do. You have to click on the S icon. Okay. So do not forget to mention scale. Okay, so always remember scale. Okay, so some of you completed. Okay, for others who did not complete till now, so I'm just gonna do it for you. You can just look at the screen, and maybe after the class you can also try it uh, on a graph paper if you have it. Now I believe from today onwards all the restrictions have been removed, and your shops, everything will be open. So please go buy a graph book. Always helpful. Please buy a graph book and start doing in the graph book itself. Okay, so some of you have, very good, okay, Prithvi and all, okay, but others, if you don't have, please bite, do it in graph. Okay, so I'm just going to mark the points. So the first point I have is 0, 0. I'm marking in green color so that you know what points I'm marking. The second is when time is 1 second, when time is 1 second, velocity is 3 meter per second. So hence the second point will be 1, 3, 1, 3. Okay. The next point is 2, 6. Okay. So 2, 6 like this. Then we're going to have 3, 9. Okay. So 3, 9. And then we have the last point 4, 12. So now when I join all these points using a straight line, so what do I get? I will get the graph. Okay, so I'm just gonna join all this using a straight line, using a straight line. Okay, so now this is our graph. So I'm just gonna make this as the points. Okay, so these are the points, and the graph that I got is a straight line graph. Okay, but what does this indicate? Okay, so this graph indicates uniform acceleration. Okay, this graph indicate uniform acceleration, not uniform motion. This graph indicates uniform acceleration. Okay, why is that so? I will tell you in the next slide. Okay, so please write this fast and put the table, put this box what I mentioned. So this is the graph for uniform acceleration. In VT graph, the straight line indicates uniform acceleration, not uniform motion. Uniform motion, Allah. You just keep this in your mind. Whenever you have an acceleration, that is not a uniform motion. Okay, uniform motion means same velocity or same speed. Here it is changing. Okay, you see the velocity is changing. Okay, so this is an example of uniform acceleration. So in the previous slide we learned that the slope indicates acceleration. Okay, over here let us find that slope. Okay, let us find the slope and look at our acceleration. Okay, so if you're done with this, so please click on the S icon so that I can use the next slide for explaining the slope. Okay, or let's just take a photo quick. Fine. Okay, cool. So now let us see how to find the slope for this graph. Same logic, same idea. I'm just going to, for simplicity, mark some points. I'm just randomly taking, I'm taking this as my point A and this as my point B. Okay, so that is our point A is 2, 6. 2, 6. I'm taking it as my point A, and 4, 12. I'm taking it as my point B. Okay, I'm going to write it here. So I'm going to use these points for finding out my acceleration, that is the slope. Okay, do not worry if you're not understanding. I'm going to explain it again. Okay, so have patience and just watch. Don't take tension. Life is simple and easy. Okay, whatever doubts, anything you have, wait, don't panic. Okay, you're not writing some IAS exam or whatever. Okay, this is just simple chota concept. Okay, chumma, why are you taking tension? So I'll just complete this and again I'll rewind. I'll explain. Okay, have patience, cool. Okay, relax. So the next slide is the slope. Okay, so the slope indicates acceleration, indicates acceleration. So we are aware of that. So how to find the slope? So the slope of the graph, okay, is equal to y2 minus y1 divided by x2 minus x1. Okay, so where I am considering the points. I have written no. I'm considering the points A and B. Okay. So what is my point A? My point A, as you can see here, is 2 comma 6, and point B is 4 comma 12. Okay, so hence let us write the same points here. Okay, so this is 2 comma 6 and 4 comma 12, and as soon as you write this, no, please indicate your x1 y1 and x2 y2, so that it is easy, you won't get confused. That's all. That's the whole idea. Okay, so now what is my y2? Y2 is 12 and y1 is 6. Similarly, what is my x2? X2 is 4 and x1 is 2. So when I do this, so I will get the answer as 3 meter per second square. Okay, and this is my acceleration. Okay, so this is my acceleration. Okay, so how you can see that every time the velocity changes, the velocity, carefully observe, it is just common sense. Okay, so every time the velocity changes, you watch, at every time I'm doing in yellow color. Okay, every time the change is how much? 3. How much is the change? 3 meter per second for every second. Okay, for every 1 second, for every 1 second, the velocity is changing by 3 meter per second. Okay, so that means I'm going to write it here, the velocity is changing 3 meter per second for every second. Okay, that straight away gives me 3 meter per second square. Okay, which is nothing but our acceleration, which is nothing but our acceleration, or the slope of the graph itself. Okay, so that is basically how you calculate. Okay, so hence for everything you can see, the acceleration is going to remain the 3 itself. You do not believe, you can take any other points. I have taken points A and B. You can take any other points on this line itself. Okay, and you can verify after the class. You will always get the answer as 3 meter per second square. Okay, and you can see uniform. Okay, so uniform means constant or same. Okay, uniform means same or constant. Acceleration is same throughout the motion, or is constant throughout the motion. That is 3 meter per second itself. 3 meter per second itself. Okay, so hence using this concept, we have learned the first important interpretation, that is the slope. So now let us move on to the second one, that is area. Okay, that is area under the VT graph. Okay, so how to find the area under the VT graph? Okay, so over here, the same example I'm taking. Suppose I want to find the entire area of the graph. Okay, so that is from the point, I'm going to just change it. Okay, so from the point that is 0 comma 0 till the end. Okay, so I'm going to rub all this. Where is my line? Okay, cool. So I'm going to take this point 0 comma 0 as my the first point. Okay, so because that is from where our motion starts. Okay, so I'm taking the point as point A. I've written in this one, A, alphabet A. Okay, so now if I have to find the complete displacement, or the distance traveled in this motion, all I'm going to do is draw the perpendicular line like this. Okay, and I have to find the entire area. I have to find the entire area of the graph, or whatever interval they give. they can just choose they will tell only from 0,0 till 2,6. If they ask you to find only from here till here, then you take that as the B point and find it. Okay, whatever interval they will tell, you choose those points. Okay, so over here I'm taking up the entire interval. Okay, so I'm taking up the entire interval. Okay, so that is pura from 0,0 till 4,12, the entire interval I am taking. So I have to find this area. If you carefully observe, what is that area? That is the area of the triangle. Okay, that is the area of the triangle. Okay, so in the next slide I'm going to write it here. So area of, or area under VT graph. Okay, so area under VT. VT means velocity time. V means velocity. T is time. Area under VT graph indicates distance. Okay, distance or magnitude of displacement. Okay, magnitude of displacement or distance itself. Okay, so how to find this area? Okay, so this area is our area of triangle. Area of triangle. Okay, so what is that area of triangle? Half base into height. Half base into height. Okay, so now when I come back to the triangle, how much is my base? How much is my base? So I'm going to take the color. Which color? Some color. I just took some purple color. Okay, so this is my base. Okay, so how much is my base? 4 units. 4 units is my base. Okay, and how much is my height? How much is my height? My height is 12 units. Okay, so now I'm going to come back to this. Okay, and substitute the values. Half base is 4, height is 12. Okay, so if I solve this, I will get the answer. So that is, if I cancel it out, 2 ones are 2 twos are 12 twos are 24 units. Okay, 24 units, or I can just write it as 24 meter, because I know unit of distance is meter. So I can write the answer as 24 meter. That's all. That is how you solve area under the VT graph. Okay, find out the shape. Find out the shape. Okay, so whatever is the kind of shape that you come across, that shape you find the area, and that area will give you the distance or the magnitude of displacement. Okay, so hence that is your second topic, that is the area under the VT graph. Okay, area under the VT graph. Okay, so which gives us the distance or displacement. Okay, so we're gonna solve some more questions based on this. Okay, so today in the group I'll just upload another practice sheet fully based on this VT graph. Okay, velocity time graph for practice. So please try it out. Okay, if you have any questions or something, so tomorrow before the class we can discuss. Okay, if you want, I'll only come early before the class. Okay, so I'll finish the other class jaldi, and I'm going to come early so that we can have some doubt solving sessions. Okay, so but trust me, it is simple. It is simple and easy. You just have to remember two things. Slope means acceleration. Area means distance. That's all. Keep that in your mind and look at the graph carefully. Look at the graph carefully and solve. Look at the graph carefully and solve. Okay, I have done the both part. I have done the slope also, and I found out the answer as 3 meter per second square, and I have also solved for the area. Okay, that is my distance. Okay, so and I've got the answer as 24 meters. Okay, 24 meters, and hence that is how you're going to solve the questions. Okay, fine. So now I will just show you the general nature of the VT graph. Okay, how does it look for rest or uniform motion, non-uniform, everything. Okay, fine. So if you're done with this, okay, quickly click on the S icon. Okay, so if you're finished with this, click on the S icon. Okay, or you take a photo, that's a better idea. Okay, cool. So now let us see the last part, that is nature. Okay, so nature of VT graph. Okay, please remember these shapes, very important. Looking at the shapes only, you can straight away tell what type of motion is being undergoing. Okay, so now nature of VT graph, nature of VT graph. Okay, so you're gonna have the following types. So I will just quickly draw the types. So they'll always try to confuse you. Do not get confused. Do not get confused. Okay, there's some more, but on the screen I will do 3 graph at a time. Okay. So remember, all of these are our VT graph. Okay, so V means velocity. Okay, VT graph. So now watch carefully. Okay, so please understand what I am doing. Okay, I'm gonna write what it means also. Okay, so this is our, the first graph is our uniform motion. Okay, uniform motion. I'm gonna write the reason also why the graph is like that. Okay, why the graph is like that, because over here same velocity. Okay, that means in uniform motion velocity is same. Okay, if the velocity is same, that means the graph will be just a straight line like this. Okay, just a straight line parallel to x-axis, because velocity is not changing. Okay, velocity is not changing. Okay, so hence, so that will be our uniform motion. Okay, so that will be our uniform motion. Okay, and that is our first type. Okay, so usually people will get confused. Do not get confused. Do not get confused. Uniform motion in VT graph looks like this. If you ask me, this is the most important graph, because every time they're gonna ask this. Okay, I put the green box. Okay, they're gonna ask this, because people get confused that this is for rest. Okay, you had learned in the displacement, distance versus time graph. Okay, but that was different, this is different. Okay, I've written the reason also, don't get confused, please. Okay, so the next one that we have, that is the straight line that we're gonna have here. So this is uniform acceleration. This is uniform acceleration. What uniform acceleration? Positive. I'm going to write the stuff in the bracket also. Positive acceleration. Okay, uniform acceleration only, same acceleration but positive. Why positive? Because the graph slope is increasing. The graph slope is increasing. Okay, so hence we call this as positive uniform acceleration. Okay, the next one what I have written, the last one. So this is also uniform acceleration only, but over here it is negative. Okay, it is negative acceleration. Okay, over here the acceleration is same, but it is negative. Okay, it is in opposite direction. We had learned about types of acceleration: positive acceleration, negative acceleration. Over here it is negative acceleration, that is opposite direction. Remember, when we can have negative acceleration? When we apply brakes. when we apply brakes to the vehicle will eventually come to a stop, okay, having an opposite or negative acceleration. You also call that as deceleration, or you also call that as retardation. Okay, so that is what we have over here. Okay, so now you can quickly write down this fast. Okay, so I'm going to mention it here, brakes. Okay, so you note it down. Okay, so the nature of VT graphs. Okay, so fast, and then we can have an chota concept test. Okay, and then I'm gonna end the graph. Okay, so I told no, negative acceleration, retardation, deceleration, just one and the same. They're just synonyms. Okay, so you just write it down what you see on the screen. Okay, so this is your nature of VT graph. Okay, nature of VT graph. Okay, so over here, uh, all the lines are straight. Over here, all the lines are straight. Okay, so maybe it might not look straight, but actually I mean straight. Okay, so I mean straight. Okay, so if you're done, just please click on the S icon. Okay, fast. So uh, do not worry. Again, in the next class, I'm going to start with the same thing itself. Okay, I'm going to start with the same thing itself. Okay, so that you still may be having some doubt. Okay, so we're gonna discuss about the same. Okay, so this is our VT graph, the displacement versus time graph, and distance versus time graph. They're almost ditto. Okay, similar types, similar types. And the distance versus time graph, the nature, everything I have given, similar types, similar types. Okay, so here in the VT graph we have different types, different nature. Okay, and all the lines that you see are straight, all the lines that you see here are straight. Okay, so if this is the case, then what does it indicate? I have written in the bracket also. In the first case, it is uniform motion indicating same velocity. In the second case, it is uniform acceleration, positive, because it is going up. Okay, in the second case, I mean the same line with the same slope, negative acceleration. Okay, negative acceleration. Okay, so where it is in the opposite direction, that is what I mean. Okay, so the sorry, the line may not look straight, but I meant it to be straight. Okay, so regarding the other things, okay, so I'm gonna again discuss in tomorrow's class. Okay, the reason, everything about this I have mentioned in the bracket. The first one, why uniform motion, same velocity for every second it is changing, the velocity is not changing, it is just going to remain same. That is why you end up having a line parallel to x-axis. Okay, line parallel to x-axis, the straight one. Okay, so hence that tells us the uniform motion of same velocity. Okay, so now before I quickly end, because your Mohit sir, he's having his class. Okay, so I just want to have a concept test. So this has multiple graphs. Okay, so you have to select the correct option. Okay, so I'm just doing freehand. I mean everything is straight line. Everything is straight line. Do not ask me, sir, this is curved on. Everything is straight line. I'm just doing freehand. I don't have scale unlike you, and I can't change the settings. It's just gonna kill time. Okay. Every line is straight line. Okay. So the first graph, the dt graph. The second one, the vt graph. Okay, so now what does both graphs indicate? Okay, what does both the graphs indicate? So option A, uniform acceleration. Option B, uniform motion. Option C, non-uniform motion. And option D, none of these. Okay, and option D, none of these. Okay, so watch carefully. The first one is a dt graph, the second one is a vt graph. Both the graph indicate same thing. Okay, what is that thing? You can just go back the previous pages and you can see the answer. Okay, so I'm going to launch the poll. Okay, so on your screen you can select the answer. So Amaya, I am telling the displacement time graph and the distance time graph both have similar nature. Distance versus time graph, I have taken 2 classes to explain Pura. Please go back and see the notes and you're going to understand everything. If you do not understand, just let me know later. Okay, Saket, how to find the distance of the first type? Wait, I will just finish this concept test and then we're gonna just see that answer. Okay, so I'm gonna close the polling. Okay, I'm gonna share the result. Okay, so on your screen you can see the answer. Okay, so 57% of you have selected the correct answer. Okay, so remaining almost half of you, close to 40%, have selected wrong. Okay, see, you just go back to the previous slide. What did I tell you? I have put this in the box also. Okay, how can you make mistake? I have told you this is important, and in the box I have put the graph and I have also mentioned something. What did I mention here? Uniform motion. I mentioned uniform motion. Okay, straight answer, man, directly. And then the other day also, when we were doing the distance versus time graph. Okay, so long ago. So where is that? My page. Okay, see here. Okay, so distance versus time graph. Okay, so if you remember, what can you see, man? Are you guys blind? How many times should I tell you? You just have to remember this photo. You cannot remember. You make a chart or something, put it on your wall. Okay, put it on your wall. Distance time graph, these are the 3 things. Okay, take a photo, screenshot. You look at the first thing. What can you see here? What can you see here? Uniform motion in distance versus time graph looks like this. Okay, whereas the same uniform motion, if you look under the same uniform motion in the VT graph, okay, in the VT graph, it is like this. I put the green box. How can you make mistakes? Okay, half of the class. Come on, you cannot do this. Okay, so just go home. You cannot come to the class as if you're attending a film or a movie. Don't come to my class unprepared. It is suicide, I'm telling you. Before coming to my class, 5 minutes, open and see what all things we did in the previous class. Okay, what all things we did in the previous class. That's all. tomorrow's class, I'm telling you, come prepared with today's nature of the graphs of VT graph. Only VT graph, whatever I did today. You just have to come prepared with this. That's all. Okay. Whatever we did today, you read once. You read once and come. I have made it very simple. Okay. So you just have to read once and come, and trust me, you will understand everything. Okay. Do not be clueless. Do not be clueless and don't take tension. Okay. Life is simple. So tomorrow again we'll continue. Read and come. Okay. Read and come. Go through the graphs and come. I just want the nature of the graphs. That's all. You will expect questions based on nature of the graph itself. Okay. Cool. So anyways, not to worry. So tomorrow we'll again continue with this itself. Okay. So if you have queries, you come early. Okay. So madam will be there. So I'll also try to finish my other class and come early so that we can clarify the distance. And regarding the Saket question, how to find the distance of the uniform motion? Are you draw this man dotted line? What figure is this? What figure is this? This is your rectangle. Find the area of the rectangle. You will get the distance. That's all. Find the area of the rectangle. If you have to find the area of the rectangle, then you will get the distance. That's all. Okay, you just have to join the points, draw the perpendicular line to the x-axis and find the area. Okay, so this area is our distance. Okay, so this area is our distance. That's all. Okay, cool. Don't worry. So tomorrow again we'll be doing this topic itself so that everybody understands. Okay, so you remember my motto. Okay, so my motto is everybody, I will write properly, man. Everybody should understand everything. Okay, and you should get good marks and be a topper. Everybody. I don't care how much you're scoring in other subject, but my subject, you follow what I say, I'm definitely gonna make you one of the toppers. Okay. What I'm saying today is read and revise. What you should read and revise. DT graph and VT graph. Do not come unprepared. You will suffer. Okay. Come prepared. Come prepared. Just go through the notes and come. 15 minutes it will take. 15 minutes. That's all. 15 minutes. 15 ನಿಮಿಷ ಓದಿ ಬನ್ನಿ. Okay. ನಾಳೆ ಸಿಗೋಣ. Thank you so much. Okay, I'll meet you tomorrow, 4:15 or something. I'm going to come early tomorrow. Don't worry. Okay, tomorrow, 4:15. Okay. Thank you so much. Homework is this only, man. This only homework. You are not at all doing the classwork part correctly. You read, revise, plot your own graph. Okay, we'll meet tomorrow. Thank you so much. So I'm going to hand it over to Mohit sir.